So we can improve significantly on that previous design by moving to what's called a multi-channel wire. So the main problem with the previous design was we had all our cells in a single line, and in order to change the behavior of the cell at the end of the wire, we needed to work our way through and actually modify the last cell in that line to control whether or not it was asserting its C output into the target cell. So what we're going to do is simply make a pair of wires as so. Okay, so this is going to be called a multi-channel wire. We're going to have two channels. This is called the program channel, and this is called the control channel. These two cells here are called head cells, and this is referred to as the head of the wire. And this cell right here, that's the target cell. And the way this works is as follows. The D input to the first cell on the program channel is transferred through all of these cells as data and is eventually loaded into the D input of the target cell. The D input coming into the first cell on the control channel is transferred through all of these cells until it gets to the head cell. And the head cell is different. It transfers the D input from the west to the D output on the north. And the head PC cell takes the D input from the south and sends that into the control input of the target cell. So by using this two lines of cells but having a slightly different configuration in these head cells, we now have direct access over the configuration of this target cell. All we have to do is modulate the D inputs on these two channels, and by setting this D input to a 1, we can put this cell into C mode, and we can put in 1s and 0s on this D input and load the cell's truth table. And if you make bidirectional wires, you can read truth tables back and so on. But when we're done and we've configured this, all we have to do is set this D input to a 0, and this cell goes back into D mode and begins in some sense executing its program. So that solves the problem of having to reconfigure the cell at the head in order to turn on or off the C mode operation of the target cell. The problem is, how do we extend this? How do we change this from a wire that's 3 cells long to a wire that's 4 cells long? And to do that, we need to do the following. We need to configure this cell here to take data and send it out to the north. And we need to configure this cell here to take data and pass it over there, and take data from the south and pass that into the C input of the cell on its east. So that gets us most of the way to an extension of the wire, and we've changed the target cell from being right here to being right here, with one small problem. The problem is, when we assert our D input on the control channel, this cell is still configured to take this value coming in and feed it into the C input, and we're still going to be configuring this as the target cell. So in order to do this, we need to break this connection here. We need to either change this cell so that it's no longer routing the southern D input to the control input, or we need to change this cell so that the control channel signal is not sent to the north. If we can do either of those, then we can no longer be configuring this cell, and we can take our C input, our D input on the control channel, and use that to configure this new target cell. The problem is the timing of this. As soon as we change either this cell or this cell, we lose the ability to configure this old target cell, which means that we need to set this up correctly in its final configuration, and we need to have this set up correctly in its final configuration before we change either of these cells. But that's not possible in a direct approach, because in order to configure this cell, for example, we need to use this cell to talk to this one to configure this. Or we need to use this cell to somehow come back and modify this. So if we're using this former target cell to reconfigure these as needed, as soon as we're finished configuring these, we can't configure this target cell anymore, because that's what we've done. We've broken the ability to control this thing's C input, which means this thing's configuration is fixed now. And if it's not set up as this final configuration that routes data south to control east and data west to data east, if it's not set up like that, we don't have control over this new target cell. We have a malfunctioning wire. So the question is, how can we extend this wire in a way that lets us stop controlling this old target and start controlling this new target both at the same time? So that's the trick of an extendable wire, and the next lecture we'll look at the details of how we make that happen, and it's actually very simple.